NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics video. Today, we're going to learn about combining like terms in algebraic expressions. When working with algebraic expressions, we often need to simplify them by combining like terms. Like terms are terms that have the same variables raised to the same powers. For example, 3x and 5x are like terms because they both have the variable x with an exponent of 1. Let's look at our first example. To find the sum of several expressions, we only combine like terms and leave the unlike terms as they are. Let's break down this example step by step. We start with the expression x plus y plus 2x plus 3y. First, we rearrange the terms by grouping like terms together. So we have x plus 2x in one group and y plus 3y in another group. Then we combine the like terms x plus 2x equals 3x and y plus 3y equals 4y. So our final simplified expression is 3x plus 4y. Now, let's look at another example that involves squared terms. We have the expression 2x squared plus xy plus 3x squared plus yx. Notice that yx is the same as xy since multiplication is commutative. So we have like terms xy and yx. We also have like terms 2x squared and 3x squared. Let's solve this step by step. We start with the expression 2x squared plus xy plus 3x squared plus yx. First, we rearrange the terms by grouping like terms together. So we have 2x squared plus 3x squared in one group and xy plus yx in another group. Then we combine the like terms. 2x squared plus 3x squared equals 5x squared, and xy plus yx equals 2xy. So our final simplified expression is 5x squared plus 2xy. Let's summarize what we've learned about combining like terms. Like terms have the same variables with the same exponents. When simplifying expressions, we identify and group like terms together. We add the coefficients of like terms while keeping the variable part the same. Remember that due to the commutative property of multiplication, terms like xy and yx are considered like terms. This technique helps us simplify algebraic expressions efficiently. In this video, we'll learn how to simplify algebraic expressions by combining like terms. We'll walk through several examples to help you understand the process step by step. Let's look at our first example. We have the expression open parenthesis 4y plus ax close parenthesis plus open parenthesis x plus y close parenthesis. The first step is to remove the parentheses using the distributive property. Since there are no negative signs outside the parentheses, we can simply remove them and keep all the terms as they are. Now we combine like terms. We'll group the terms with the same variables. We have 4y plus y, which gives us 5y. Then we have ax, and finally we have x. Now, let's look at our second example. We have the expression open parenthesis 2a plus 3b minus 7 close parenthesis plus open parenthesis 5a minus 4b minus 3 close parenthesis. Let's begin by rearranging the terms, grouping similar ones together. First, we'll rewrite the expression as open parenthesis 2a plus 5a close parenthesis plus open bracket 3b plus negative 4b close bracket plus open bracket negative 7 plus negative 3 close bracket. Now, let's combine the like terms within each group. 2a plus 5a equals 7a. 3b plus negative 4b equals negative b. Negative 7 plus negative 3 equals negative 10. Finally, let's look at our third example. We have the expression open parenthesis 3a squared plus 5a close parenthesis plus open parenthesis a minus 2a squared minus 5 close parenthesis. First, let's regroup the terms by like powers of a. We'll group the a squared terms, then the a terms, and finally the constants. We have open parenthesis 3a squared minus 2a squared close parenthesis plus open parenthesis 5a plus a close parenthesis minus 5. Now, let's combine the like terms within each group. 3a squared minus 2a squared equals a squared. 5a plus a equals 6a. And we still have negative 5. We need to find the sum of the following expressions. To add these expressions, we'll first remove the parentheses and then combine like terms. Let's start by removing the parentheses. Now, let's combine the like terms. For the x squared terms, negative 10 plus 13 equals positive 3. For the x terms, 1 minus 9 equals negative 8. And for the constant terms, negative 45 plus 4 equals negative 41. Quick challenge. Can you predict the solution to our next example before it appears? Take a moment to write down your answer before we continue. Let's move on to our second example. Just like before, we'll first remove the parentheses. Now, let's combine like terms. For the x squared terms, we have negative 2x squared plus 7x squared, which equals 5x squared. Quick challenge. Try to solve our final example before we show the solution. Take a moment to work it out. Let's tackle our final example. Again, we'll remove the parentheses first. This gives us x squared minus y squared plus x squared plus 2y squared. Now let's combine like terms. For the x squared terms, we have x squared plus x squared, which gives us 2x squared. For the y squared terms, we have negative y squared plus 2y squared, which equals y squared. Let's summarize. Today we're going to solve a polynomial addition problem step by step. Let's look at our example. We have two polynomials, a and b, and we need to find their sum a plus b. Polynomial a is defined as x squared over 3 minus 2x over 5 minus 1. Polynomial b is defined as 2/3 x squared plus 12/5 x plus 3. Step 1. Let's substitute the expressions for a and b into the sum a plus b. We write a plus b equals the expression for a plus the expression for b. So that's x squared over 3 minus 2x over 5 minus 1 plus 2/3 x squared plus 12/5 x plus 3. Step 2. Let's rearrange the terms to group like terms together. We'll group the x squared terms, the x terms, and the constant terms. So we have x squared over 3 plus 2/3 x squared. Then we have negative 2x over 5 plus 12/5 x. And finally we have negative 1 plus 3. Step 3. Let's factor out the common denominators in each group term. For the x squared terms, we can factor out 1/3, getting 1/3 plus 2/3 times x squared. For the x terms, we factor out 1/5, getting negative 2 plus 12 times x. The constant terms remain as negative 1 plus 3. Step 4. Now let's add the fractions within each group. 1/3 plus 2/3 equals 3/3, or simply 1. Negative 2/5 plus 12/5 equals 10/5, or simply 2. And negative 1 plus 3 equals 2. Step 5. Let's simplify our fractions. 3/3 equals 1, and 10/5 equals 2. So our expression becomes x squared plus 2x plus 2. Therefore, our final answer is a plus b equals x squared plus 2x plus 2. This is a second-degree polynomial in standard form. Let's summarize what we've learned. To add polynomials, we 1. Substitute the expressions. 2. Group like terms. 3. Factor out common denominators. 4. Add fractions within each group. 5. Simplify the fractions. This process works for adding any polynomials, regardless of their degree or complexity. Today we're going to learn about adding algebraic expressions. This is an important skill in algebra that will help you solve more complex problems later on. When adding algebraic expressions, we combine like terms. Like terms are terms that have the same variables raised to the same powers. For example, 2x and 3x are like terms because they both have the variable x with the same exponent, which is 1. Similarly, x squared y and negative x squared y are like terms because they both have x squared y. Let's look at an example. We have two expressions a and b. A equals 2xy minus 3x minus x squared y plus 7. B equals 7x plus 11 minus 3xy plus xy squared. Our task is to find a plus b. To do this, we'll add these expressions by combining like terms. Let's start by writing out what a plus b means. We substitute the expressions for a and b into our equation. A plus b equals the expression 2xy minus 3x minus x squared y plus 7, plus the expression 7x plus 11 minus 3xy plus xy squared. Now, we'll group like terms to make our addition easier. We can rewrite this as 2xy minus 3xy, which are like terms involving xy. Then negative 3x plus 7x, which are like terms involving x. Next, negative x squared y, which doesn't have like terms with other expressions. Then 7 plus 11 for our constants. Finally, xy squared, which also doesn't have like terms with other expressions. Now we can combine our like terms. 2xy minus 3xy equals negative xy. Negative 3x plus 7x equals 4x. Negative x squared, y remains as is. 7 plus 11 equals 18. And xy squared remains as is. So, a plus b equals negative xy plus 4x minus x squared, y plus 18 plus xy squared. So, our final answer is a plus b equals negative xy plus 4x minus x squared, y plus 18 plus xy squared. Let's look at our problem. We have, if c equals 3 and a plus 2b equals 5, then find the value of a plus 2 times the quantity b plus c. First, let's break down what we're trying to solve. We want to find the value of a plus 2 times the quantity b plus c. We know that c equals 3 and a plus 2b equals 5. Our first step is to expand the expression. Using the distributive property, we can rewrite a plus 2 times the quantity b plus c as a plus 2b plus 2c. Now let's regroup the terms. We'll group a plus 2b together, since we know this equals 5 from our given information. Using our given information, we know that a plus 2b equals 5. So we can substitute this into our expression. Next, we substitute c equals 3 into our expression. Finally, we calculate 2 times 3, which is 6, and add it to 5. 5 plus 6 equals 11. Therefore, the value of a plus 2 times the quantity b plus c is 11. To summarize the solution process, we first expanded the expression using the distributive property. Then we grouped terms to match our known information, and substituted the values of a plus 2b and c. After calculating, we found that the value of a plus 2 times the quantity b plus c equals 11. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.